Hello everyone. Let us assume that we've been given the trigonometric ratio sine of theta is equal to 1 by root 2 and we've been asked to find cos of theta. We have done similar problems in our own channel, in the Math Decoded channel, but the purpose of this video is not just solving what is cos theta, but let us do that first. So how do we go about this problem? So this, we have a right angle triangle, it's right angled here, and this is angle theta. So sine theta by definition is the length of the opposite by the length of the hypotenuse. So if which is the opposite side here, this is opposite to theta, and the longest side, the side across the right angle, is the hypotenuse. So we have been given that the opposite side is since the ratio is 1 by root 2, the opposite side is a multiple of k1k and hypotenuse is root 2k. And so now in order to find cos theta, we'll have to find the third side, the adjacent side. How do we find it? We use the Pythagoras theorem. The Pythagoras theorem states that the length of the opposite side, the square of the length of the opposite side added to the square of the length of the adjacent side, that is the sum of the squares of the two legs of a right angle triangle, is equal to the hypotenuse square. So we use this theorem in order to find the third side. How do we use it? So let me call this maybe some x. What is our x? X would be equal to hypotenuse square minus opposite square, isn't it? Or it would be equal to root 2k the whole square minus 1k square. In fact, the square root of this. So it is the square root of this. We are just finding the length of the adjacent side. It is the square root of hypotenuse minus opposite squares both. So this is equal to the square root of 2k squared minus k squared or root k squared, or our adjacent is also equal to 1k. So cos theta can be established here because we know that cos theta by definition is the length of the adjacent by hypotenuse. So it is 1k by root 2k, or this is also equal to 1 by root 2. Now this problem which we have done begs for a relationship between these two trigonometric ratios, sine of theta and cos of theta, isn't it? Because they are related in some way to one another, sine theta and cos theta. So this is clear from what we have done here. So what can that relationship be? Let's try to find out what that relationship is. For that matter, let's take another triangle. Let's consider a right angle triangle, and let's call the triangle ABC. It's right angled at B, and this is theta. Angle C is theta. So this is the opposite. This is the side opposite to theta. So let's just go about doing it. So we have to establish a relationship between sine and cos. So what is sine theta here? It's opposite by hypotenuse. So it is AB by AC. And what is cos theta? From this figure, the cos of theta is adjacent by hypotenuse, so it is BC by AC. Now the previous problem which we did indicates that the relationship is between the squares of sine and cos. So let's try to square and see what happens to both of them. And let's square sine theta first. Now sine theta the whole square is equal to sine square theta, isn't it? And of course it is not equal to sine theta squared. So we'll have to have this in mind. Sine theta the whole square is sine squared theta. Now what is sine squared theta? Sine squared theta here is AB squared by AC squared. And let's also square both the left and the right hand side of this. So cos squared theta is equal to BC squared by AC squared. Now we'll have to arrive at a relationship between these two, sine and cos. What do we know about this triangle? We know that in this triangle, AB squared plus BC squared is equal to AC squared. This is what the Pythagoras theorem tells us. Being a right angle triangle, the sum of the squares of the legs of these two, the squares of the legs of the triangle will be equal to the square of the hypotenuse. So we know this. We'll have to keep this in mind now. AB square plus BC square is equal to AC square. And let us just add both of them, because if you look at the numerators, you have AB square here and you have BC square here. So let's try to add both of them, which is we will add the right hand sides first. Cos square theta, adding both would be equal to AB square by AC square plus BC square by AC square. And now since the denominators are equal, this can be written as AB square plus BC square by AC square. Now what is our numerator? It's AB square plus BC square. It is equal to AC square. Oh, I've gone too far. Yeah, this is equal to AC square by AC square, or this sine squared theta plus cos squared theta is equal to 1. So this holds for all thetas. So we have arrived at a relationship between sine theta and cos theta. It says that sine squared theta plus cos squared theta is equal to 1. And this holds good for all thetas. Whatever theta might be, the relationship is the same. How does it help us? How does this help us? Now, in the problem which we started off with this video, we were given what was sine squared theta. It was 1 by root 2, and we were asked to find cos squared theta. Instead of drawing a triangle, finding out the length of the adjacent, etc., just using this relationship, how we can find cos squared theta just by cos squared theta would be equal to 1 minus sine squared theta. We've just rearranged the equation. We have subtracted sine squared theta both sides, right? Rearranging the equation, you can solve the problem. You could have easily found what was cos squared theta. Cos squared theta would be equal to 1 minus 1 by root 2 the whole square. I think I should change my ink. Yeah. Or I am doing that same first problem again. So 1 minus 1 by root 2 the whole squared is half, or 1 minus half is also half. So we could have easily found cos theta without going through all those steps. Cos theta would have been equal to 1 by root 2 by taking square roots of both sides. I hope this helped, and the purpose was to establish this relationship between sine theta and cos theta, and how it can be applied to all our problems. Thank you.